Hello guys, welcome to Ramta Solutions. Today we are looking at stoichiometry and we are going to help you to excel with stoichiometry. So without any waste of time, let's say given a balanced chemical reaction or chemical equation, okay, let's imagine it. So let's say this is our chemical equation: small letter A, capital letter A, plus small letter B, capital letter B, giving us small letter C, capital letter C, plus small letter D, capital letter D. So these A and B are what we term reactant, all right? These are what we call reactant for the forward reaction, of course, but of course in this reaction it's only a reactant, and these, the substances on the right hand side, are what we term products, all right? So when you come to stoichiometric calculations, always ensure that your chemical reaction or your chemical equation is balanced, okay? Always ensure that your chemical equation is balanced, okay? So after balancing your chemical equation, these are the things that you need to know. You need to know that the ratio of the number of moles of substance A over its coefficient is equal to the number of moles of substance B over its coefficient. It's also equal to the ratio of the number of moles of substance C over its coefficient, which you can also say it's equal to the number of moles, the ratio, of course, of the number of moles of substance D over its coefficient. So you don't need to write all of these as they are. You can just say, if you are given substance A, you can find substance B, you can find substance C, you can find substance D. So basically, this means this is equal to this, or you can say this is equal to this, or you can say this is equal to this. It depends what you are given, okay? It depends what you are given. Now note, these are Na is the number of moles of a substance, while A, small letters A, B, C, D are the coefficients in a balanced chemical equation, okay? They are the coefficients in a balanced chemical equation. So now we will try an example where you will get to use this, okay? So now our example, we will say 6 mole, okay, 6 mole of Al, or aluminium. Let me just write aluminium in full. 6 moles of aluminium react with hydrochloric acid. The reaction is aluminium plus, let's say aluminium in solid phase, plus hydrochloric acid in, let's say, aqueous phase, giving us aluminium tetrachloride in aqueous phase, of course, plus hydrogen, maybe let's call it, okay, it's a gas phase. Let's just say it's a gas phase. Okay. So now the first thing that the question that you will have is this. They say to you, now how many moles, let's do it, how many moles of number 1, HCl are required. Number 2, how many moles of aluminium tetrachloride can be formed? Can be formed. Okay, can be formed. Let me put a question mark. And the third question, how many moles of H2 can be formed as well? Let me just say can be formed. Okay. So this is your stoichiometric calculation. First thing first, you have to ask yourself, is my chemical equation balanced, or chemical reaction, does it look like the equation is balanced? Let's see. Aluminium, okay, it's not balanced as yet. Okay, it's not balanced. Perhaps let me try to see what I can do. Maybe let me try to say put a 2 here and then balance the aluminum here. They seem balanced. And then I see we have 3 times 2 chlorines, which is 6 chlorines. So maybe we will have to put a 6 here. And this is 6 hydrogens. Here we have 2 hydrogens. So we will have to multiply them by 3. Now, our equation is balanced. Right? Now our equation is balanced. Remember, in this question, what you have the number of moles of aluminium. All right? They gave you the number of moles of aluminium. So now let's answer the questions. Number 1, they said we must find the number of moles of hydrochloric acid that are required. So what you need to know is this: the number of moles of hydrochloric acid over what is the coefficient? The coefficient is 6 is equal to the number of moles of aluminium over what is its coefficient? 2. The number of moles of aluminium over 2. Now I'm going to the opening slide. Remember, in the opening slide, I said to you, you're going to say number of moles of substance A over number of moles of, over its coefficient is equal to number of moles of substance B over its coefficient. This is what we have done. Okay, the order is not important. So, what is the number of moles of hydrochloric acid? We do not know. So, it's easy for you to say, okay, this is, let me just multiply by 6 throughout. This will be number of moles of aluminium over 2 multiplied by 6, right? So what is this? Number of moles of aluminium, we had 6 moles of aluminium. So this is 6 over 2 multiplied by 3. Sorry, multiplied by 6. What is this? 3 times 6 over 2 is 3. 3 times 6 is 18. So we need 18 moles of hydrochloric acid, right? We need 18 moles of hydrochloric acid. Do you guys see it now? Okay. Even if you had not done what I had just done now, it was going to be okay. Maybe continuing by just directly substituting, it was still going to be okay. But it's okay to also do it like this. In fact, I prefer it this way. Okay? Perfect. Now, the second question says, calculate the number of moles of aluminum tetrachloride that can be formed. So, again, the number of moles of aluminum tetrachloride over its coefficient is 2. Right? Its coefficient is 2. Is equal to the number of moles of aluminium over its coefficient. What is its coefficient? Its coefficient is 2. Right? So what do we have? Number of moles of aluminium tetrachloride is equal to number of moles of aluminium over 2 multiplied by 2. Now this tells you that this is, all right? Why? This is the case because the 2 and the 2, right? but whichever you prefer. Even if you directly substitute, it's okay. Okay? Even if you directly substitute, it's okay. All right? So what is this? This means the number of aluminum tetrachloride moles that can be formed are 6 moles. Why 6 moles? This is because the number of moles of aluminum are 6, right? You have 6 moles of aluminum. Do you guys see it? So this is how you can perform your stoichiometric calculations. Now, the third question, the number of moles of hydrogen that can be formed, hydrogen gas. So let's go. Oh, this was number 2. Now number 3, number of moles of hydrogen gas over the coefficient. What was it? Was it 3? It was 3. Yes, it was 3. It was 3. And what is the number of moles of aluminum over what is the coefficient? The coefficient was 2. Again, you can say this is number of moles of hydrogen gas is equal to number of moles of aluminum over 2 multiplied by 3. Let's see. What is this? Number of moles of aluminum were 6 over 2 multiplied by 3. Now what is our answer? Our answer is simply 9 moles. Alright, our answer is simply 9 moles. So this is how you perform your stoichiometric calculations. Okay, this is how you perform your stoichiometric calculations. So do this all the time when you come across stoichiometric calculations, and you will never go wrong. All right. So this is it, guys. Bye bye.